An action potential arrives at the synaptic knob. Calcium channels in the membrane open, allowing calcium to move into the cell. Increased calcium causes synaptic vesicles filled with acetylcholine to fuse with the membrane. Acetylcholine is released from the synaptic knob by exocytosis into the synaptic cleft. Acetylcholine is then picked up by acetylcholine receptors on the motor end plate of skeletal muscle. Sodium-potassium channels open, allowing sodium ions to enter the muscle fiber. Increase in positive ions inside the muscle cell initiates an action potential on the sarcolemma. Acetylcholine esterase then breaks down the acetylcholine to allow another signal to happen again and release more acetylcholine. An action potential travels down the sarcolemma into the T-tubules and stimulates the release of calcium from the terminal cisternae of the sarcoplasmic reticulum, where it has been sequestered by calsequestrin, into the sarcoplasm of the muscle cell. A muscle cell is also called a myofiber, which is inside the fascicle of a whole muscle. Inside a myofiber is a myofibril, which contains a sarcomere, which is a highly ordered unit of thick and thin filaments. Within a sarcomere, you have an A band, which is only thick filaments, or called the dark band. You have an I band, which is only thin filaments, or called the light band. You have the Z line or the Z disc, which are the ends of each sarcomere, where the thin filaments attach. You have the H band, which is the lighter region in the A band, and there are no thin filaments. The M line or the M disc runs right down the middle and allows thick filaments something to attach to. Calcium then floats over the thin filaments and binds to troponin, pulling tropomyosin off the active site on the actin. High-energy myosin heads leap up to bind on the exposed active sites on the thin filaments, forming a cross bridge. The myosin head pivots to the low-energy state, releasing ADP and moving the thin filaments over the thick filaments, called the power stroke. ATP, made by the mitochondria, binds to the myosin head, causing the head to break free from the active site on the actin. The myosin head becomes energized as ATP is converted to ADP. Calcium is then pumped back into the sarcoplasmic reticulum and attached to the calsequestrin, allowing tropomyosin to once again cover the active site, resulting in relaxation of the muscle.